All right, in this video, we are going to just review each of the operations with radicals that we've discussed so far in this unit. And you'll notice that on this graphic organizer that we have given you guys your list of perfect squares and what their square roots are so that you can refer to them. Remember, if a number is a perfect square that's underneath the radical, when you take the square root of that, the radical is going to disappear completely. So let's do we'll do about 2 or 3 examples per either simplifying or operation. So let's start with the square root of 49. Since the square root of 49 is a perfect square, and we can see up above that the square root of 49 is just 7, we can simplify the square root of 49, and it's just a regular 7, not square root 7. Now, what if I give you 3 times the square root of 20? 20 is not a perfect square, so that means we have to break that apart. So I'm going to break the square root of 20 up into 2 radicals, one of which has to be a perfect square. So I want to know which perfect square, what's the biggest perfect square that will go into 20. And so when I look at my list of perfect squares, the biggest perfect square that goes into 20 is going to be 4. And then 4 times 5 is 20. The square root of 4 is just a 2 times the square root of 5. And then I can multiply my coefficients to get my final answer of 6 square root 5. Now, when it comes to multiplying radicals, remember we actually would multiply the radicals together. So let's do the square root of 12 times the square root of 3. And while some of you may be tempted to just start simplifying and break apart the 12, it's actually easier if we multiply the 2 radicals together and get one single radical to then we decide how we want to simplify. So square root 12 times square root 3 is the square root of 36. And 36 is a perfect square, so the square root of 36 is just 6. And then let's do 5 times the square root of 6 times the square root of 2. And so if we have any coefficients, we always multiply the coefficients together. So I just have 5. And if it's helpful, I can put a little 1 in front, and I'm essentially doing 5 times 1. And then square root 6 times square root 2 is the square root of 12. 12 is not a perfect square, so I have to break apart the 12 and ask myself, what's the biggest perfect square that goes into 12? And that answer is 4 and 3. And the square root of 4 is 2. Bring down that square root 3, and then multiply my coefficients. 5 times 2 is 10, and then tack on the root 3 at the end. When it comes to rationalizing radicals, remember you're not allowed to have a radical or a square root in the denominator. So if I give you a problem like 5 divided by the square root of 3, you're not allowed to have that square root 3 in the denominator. And so our solution to that is we can multiply by a factor of 1. And we learned that if we take the square root of 3 times itself, we're going to be left with just a 3. Well, and we also, in order to kind of do a legal move in math, we have to multiply by a factor of 1. So that means I have to multiply my numerator by square root of 3 as well. And so 5 times the square root of 3 is just 5 times square root 3. And if I look at my coefficients on the outside, that 5 and 3, that cannot be simplified. So 5 times the square root of 3 divided by 3 is my final answer. Now, if I give you a problem like 12 divided by, actually, I'm going to change this. Let's do 15 divided by the square root of 5. Once again, square root of 5, I have to rationalize that, and I can't simplify it either. So I have to multiply times the square root of 5, which will leave me with 5 in the denominator. And I have to multiply the numerator by square root of 5 as well. And so I get 15 times the square root of 5. And this is where I always got to stop and look at the coefficients that are now on the outside. I have 15 divided by 5, which I can simplify to just be 3. And then I still take it times the square root of 5. Then when it comes to adding and subtracting radicals, this is actually kind of the opposite process of what we do with multiplying. With multiplying, we multiply first, then we simplify. But when we add or subtract radicals, we want to simplify, if needed, first, and then we perform the adding or subtracting. When we add and subtract radicals, we also have to make sure we add or subtract like radicals. So if I give you 3 square root of 2 minus 6 square root of 2, my radicals are both square root 2, which means those are like radicals. So that means all I have to do is subtract the coefficients. So 3 minus 6 is negative 3, and then I have root 2 tacked on. So essentially this is like saying you have 3 root 2's and you take away 6 of them. How many root 2's do you have? Well, you would have negative 3 root 2's. Now, if I give you this problem, 12 times the square root of 50 plus 6 square root 2. You do not have like radicals. However, when you look at the square root of 50, you can pull out a perfect square. And so if you have a radical that can be simplified, you need to simplify first to see if you would end up with like radicals in the end. So like if I simplify the square root of 50, I want to know, would I end up with a square root of 2? So I'm going to take the square root of 50 and break it up into 2 radicals. That would multiply to give me the square root of 50. And so one of them has to be the perfect square. So that would be 25 and 2. The square root of 25 is just 5 times square root of 2, and I'm bringing everything else down. 12 times 5 is 60 root 2 plus 6 root 2. And so now I have like radicals. I have a square root 2 in both of them, which means now I can just add the coefficients. So 60 plus 6 tells me that my final answer is going to be 66 times the square root of 2. So hopefully by seeing all the different things that we've done with radicals, simplifying, multiplying, rationalizing, and adding, subtracting, having it all in one place, you see the differences and similarities in what we're doing, and hopefully this will help you to get ready for our test on radicals here soon.